Hi everyone, we can start now. Welcome, good morning, good afternoon, good evening, depends on which part of the world you are. I'm Valentina, I'm the ES officer, and with me today I have Faten and Claudia, they are ES members. Claudia is part of Go as well, and Sonia, she is from GAWTEC, and our speaker today will be Rebecca. Before introducing Rebecca, I will talk a little bit about the code of conduct that maybe some of you already know if you have attended the last webinars. Please be polite and respectful to the speaker and to all the participants today. You can write your questions in the chat box. We will answer it during the Q&A session after the presentation of Rebecca. And all the content, the presentation, the chat box, everything is recorded. So we will share the video after in our YouTube channel and in the YES website. I already paste the link in the chat box, but just in case I will do it again. Now I will give you the floor to Sonia.
Welcome everyone. I'd like to introduce our speaker today. It is Mrs. Rebecca Chewitt-Lucas from Barbados. She is a research officer at the Caribbean Institute for Meteorology and Hydrology, and also part of the team for Air Quality and Forecasting Center, and one of the trainers of the meteorological technician courses. Her interest lies mainly in ambient air quality, with a specific interest in Saharan dust with respect to in situ and remote sensing of aerosols. Also, she is supporting education and was involved in the instructional design of online courses for the National Meteorological and Hydrological Services. She has also a keen interest in rainfall patterns across the Eastern Caribbean regions. And she has also been working with various institutions such as the Max Planck Institute for Chemistry, and was maintaining various aerosols and greenhouse gas equipment. She also assisted Barbados Environmental Protection Department with ambient air quality monitoring equipment to monitor greenhouse gases and particulate matter. She was the liaison officer for the Eureka outreach program, which she will talk about today. The Eureka project is in collaboration with Professor Björn Stevens. He's a director of the Max Planck Institute for Meteorology, where he leads the Atmosphere in the Earth System department, and is also a professor at the University of Hanover. He was one of the lead scientists on the international field study of Eureka in the Caribbean. And yes, now we will hear about the project. And Rebecca, thank you that you're here today, and the floor is yours.
Thank you very much, Sandra. Good day, good evening to all. Just give me a minute. Let me share my screen with you. Okay, so everyone can see my screen. Okay, great. So as Valentina said, good morning, good afternoon, good evening, according to where you are. I am also a research officer at the Caribbean Institute for Meteorology and Hydrology. And we have worked with the Eureka field campaign that was started in 20th of January to the 20th of February 2020. My colleague, Professor Björn Stevens, he would have been here to assist, but he had some pressing meetings. But I will take you through a general overview because there was a lot of stuff being done for the Eureka field campaign. So I'll take you through a general overview of what it was about and give you some information relevant to data. So the campaign was an international initiative supported by the World Climate Research Program programs for Grand Science Challenge on clouds, circulation, and climate sensitivity. The question you obviously ask is, what is Eureka 4A? So is the eluding the role of cloud circulation and coupling in climate. So you can see where the bold letters are is what the name is made up of. So our main objective was to have an advanced understanding of the interplay between clouds, convection, and circulation, and the role they play in climate change. So based on that general objective, we had specific questions to ask as well. How resilient or sensitive are the shallow cumulus clouds? And cumulus clouds are usually considered to be warm clouds. Amongst the variation in the strength of convective mixing, surface turbulence, and large-scale circulation. How do the radiative effects of water vapor and clouds influence shallow circulation and convection? And what extent those mesoscale patterns of convective organization condition the response of clouds to perturbations? And what are the implications of all the above for how clouds respond to warming? So in a sense, the main focus, as I said, is to see how these clouds, especially these cumulus clouds, small, shallow clouds, impact climate change. So what Eureka did was to meet these objectives was to quantify different measurements of cloud in the trade winds as a function of their large-scale environment. So from this study, you can see that the field study or the field campaign had a large amount of institutions involved. Over 100, actually, 104 institutions involved for those four or so weeks. So it was very intensive, and it's a lot of manpower as well. So as you can see with the number of institutions, and some of them are regional within the Caribbean, some of them are European, some of them are with respect to the Americas, USA, and some of them are with respect to some areas in South America. Most of the persons that came from South America actually came from some of the European and American institutions themselves. So what brought about this Eureka 4A campaign? So from BOMEX, which was originally a field study done in the 1970s in the region. If you look at the chart, you see where Barbados is. So it was some research ships that looked at basically the same objectives that Eureka, the main objective that Eureka was looking at, quantifying the different measures of cloud in the trade winds as a function of their large-scale environment. How could they do this? What ways could they get this done? You know, the issue obviously was the difficulty in getting measurements varied in vertical aspects, horizontal aspects, because they were really ships, just ships mainly, and probably buoys and so forth. So based on this and other research studies that came up before Eureka tried to probably I can say look at these objectives based on a new methodology we have available to us in this present day. So using new methodology that is available to measuring the quantities or measuring the multifaceted clouds that we want to look at. We could use that as well as experimentation over the past decade with the Barbados Cloud Observatory to answer the major objective that was asked by BOMEX in the 1970s. So the beautiful thing about Eureka is that this time we were able to do a lot more than BOMEX in the 1970s. And with obviously more instrumentation and more manpower. So here is the field study, or the study area, sorry. If you look closely, you will see the scale at which it is. So you can see my island, Barbados. The Barbados Cloud Observatory is here on the eastern coast of Barbados. So this was one of the main platforms. You also see there is a, excuse me, there is a buoy here. This is called the Northwestern Tropical Atlantic Station. So between this area, the BCO, we had something called what we call the trade wind alley. The trade wind alley is where you have, excuse me, where you have winds traveling from the east to the towards the BCO. So that was our trade wind alley. That's an area which was used for the research as well. Also, we had an area where coming from the South American area, call it the Bolivar de Tubio. I hope I didn't destroy anybody's language. So for this area, we did a lot of activities within those 3 or 4 weeks that we had the ships, the planes, as well as the land-based or ground-based platforms. So you will see Site A, where you had studies for cloud circulation and interrelationship between mesoscale patterns and cloud physics. That was mainly circular movement of the planes. Where you see the blue is the movement of the planes. We also have Site B along here, where we had studies of the ocean on sub-mesoscale processes and the air-to-sea interaction that occurred there. And where you have Site C. Site C was where you have studies of the ocean, mesoscale eddies, and air-to-sea interactions and cloud physics as well. So there's a lot of activity going on within the area, within the study area. So you can see where the study area is at the bottom and the right corner. A lot of activity. This here is a this will come considered to be a southeastern northwest meander, where the studies, some of the study occurred. Okay, so for us in the Caribbean, our base, or for Eureka 4A, the base of the operation was at the Caribbean Institute for Meteorology and Hydrology, for short CIMH, and the chief investigators were Sandri Bun from LMD. This is a meteorological laboratory in Paris. Bjorn Stevens from the Max Planck Institute for Meteorology in Germany, and David Farrell from CIMH, who was the chief investigators. They had the first conversation probably a couple of years ago about getting this type of field campaign on the ground. Some of the lead scientists for the areas that I identified before for land-based as well as sea-based activities and aircraft activity were seen as OAs, Eureka 4A OA, which is ocean atmospheric. You had wind experimental wind activity. Atomic was the American-based research group. So all of these different institutions and groups came together to answer the main question, which was the first objective that you saw. So as I said, there were major platforms. So we had ground platforms, or land platforms, for lack of a better word. We had atmospheric platforms, and we also had ocean platforms. So our ground platforms, let's look at first at our ground platforms as the slide shows. The first ground platforms were Devil's Point, Ragged Point, and Colleton, all in Barbados. So the Devil's Point is where BCO is, the Barbados Cloud Observatory. And this was a major, or the main land-based platform. Ragged Point, which is known also, and Devil's Point, which is known also for aerosol measurements and cloud nuclei measurements and so forth. And the Colleton, which is in a parish known as St. John, which was about 8 kilometers away from Devil's Point, which is, so if you think about it, is like west northwest of Deepest Point. So it gave a good view of, gave a wide and undisturbed view to the east and the areas where the aircraft would have flew as well. So strategically, everything was put strategically to ensure you have the maximum amount of information or collection of data where possible. So that ground station at Cullerton was the Polaroid radar, weather radar. And it was put up there during the campaign. Okay, so as I said before, we had sea or ocean platforms, but we also had air platforms. So let's look at the air platform, starting from the, excuse me, starting from the top right-hand corner. We had a German high altitude plane known as the Halo, which is operated by DLR. And it flew about 13 missions in the period, and it totaled about 130 flight hours. So it was a lot of work being done there. We have the next plane, if you're coming from the first plane to the second plane, the French ATR-42 aircraft, which was operated by Starfire. This plane did a lot of missions as well within a couple of days, about 11, probably 19 missions. And each mission was about 5 hours. This is the plane that I got to spend some time on as well. Then we also have the NOAA WP-3D or Orion, which is a P3 plane. It also flew about 15 missions for 95 flight hours. It is also one of the hurricane hunters that is used during our hurricane season. And we also have the Eureka 4A UK projects plane, which is the Twin Otter, or TO for short. And that did about 90 hours of flight. And they also facilitated ground measurements close to the surface, as well as certain altitudes in the atmosphere. So those are the planes. Those were the aircraft or the air or atmospheric platforms. We had the oceanic platforms, and starting from the top on the right, we can see that the German research vessel, the Meteor, was one of the vessels that spent most of the time in the trade wind alley. If you remember when I showed you the study area, it followed there. It spent about roughly the month in that trade wind alley, which is east of Barbados, and the vessel used a variety of instrumentation to look at the atmosphere and ocean beneath it. The next ship was the NOAA Ronald Brown, and this ship also spent some time in the trade wind alley. So if you remember the study site, you know the trade wind alley was in the northern region of the study area. And it also had the goal of doing measurements and so forth with respect to atmospheric and oceanic conditions. And the last ship, which is the research vessel Atalante, which is French operated, and this spent the time along the meander that I showed you earlier on the study site. It moved from Guadeloupe right up from Guadeloupe, Trinidad, right up along towards Barbados, and it collected oceanic and atmospheric data as it moved along those areas. And last but not least, another German research vessel at the bottom here. Another research vessel, which also known as the Marine Merian, and it was also used to collect oceanic data and atmospheric profile measurements as well. So you can see, based on what I've just said, you can hear the magnitude of work that was being done in those 3 to 4 weeks. So let's look at it by the numbers. So by the numbers, you had roughly 50 research platforms, inclusive of the craft, the ships, the drones, the drifters, the ground stations, and other research platforms on a smaller scale. As I said before, we had a large set of aircraft. We identified them a few seconds ago. We have a large, 4 large research vessels. Identified them a few minutes ago. We had drones and so forth. We have more than 300 CTDs. CTDs, for those that don't know what CTDs are, those are oceanic, excuse me, instruments used to measure conductivity, temperature, and pressure, but you know, it's not PSD, but D stands for depth, and it's closely related to pressure when you think about oceanic activity. And we had a lot of universities as well, 5 universities from Europe, and many institutions from Europe as well, many institutions from Europe, from the United States as well. And we had a very successful research outreach program for the region, which we will talk about after as we go on. And there was a visit from the Deputy Administrator of NOAA to see what the research was about. So it was very vast and significant in terms of the manpower and hours and the equipment and the platforms that were there and available to us. So one of the land-based platforms, one of the major ones and the most important one to me, but I could be wrong, is the BCO, which is the Barbados Cloud Observatory, as I said before. This has been there for about 10 years now, or more than 10 years, from 2010, actually, more than 10 years. And it has been a long-term context of intense observation. And because it has that information, the combination of measurements from the other platforms also help to achieve the campaign's objectives. Now, the relationship between Max Planck Meteorology for this BCO and the Barbados Museum, which owns the land, and the CIMH, can be considered to be a precursor to the Eureka 4A event. That relationship over the years has caused this activity to be actually to come into fruition. Now, as you can see on the left, I don't know if you can see them clearly, but there was a lot of equipment at BCO, as well as some of that equipment was at Ragged Point for our land-based state platform or station. Another set of equipment that was on the land was we had 3 profiling rain radars, one at BCO, one at the CIMH, Caribbean Institute for Meteorology and Hydrology, and the third was on a ship, the Miriam, the research vessel Miriam. So instrumentation with respect to those found used on the ocean platforms, and these would be, and as I said, we can't show everything, so I'm just showing you some of the instrumentation and some of the platforms that were used. So the first one you're seeing there is a sail drone, and that sail drone, we had numerous sail drones actually, and the sail drone measured wind speed, wind direction. It also measured sunlight, infrared, it measured temperature. It did a lot of measurements, obviously oceanic measurements, like wave height, dissolved oxygen, salinity, ocean temperatures, ocean currents. So it did a lot of measurements. That sail drone, as small as it looks, is very effective piece of equipment and a platform. We also had other sail drones that were put along the ocean by some of the research vessels, or one of the research vessels for sure. I know the Brown just put down some of the sail drones, and the sail drones were between the trade wind alley. Remember I showed you in the north in the study area. Another platform is the Autonaut, and you see it here, operated by the University of East Anglia, which is The Autonaut is an unmanned surface vessel. This was put into the water at the Barbados Coast Guard, which is a military base here in Barbados. And it was also used to measure meteorological and oceanic measurements for the air and sea interface. It has been out to sea for the last 10 years. I believe they change it once every year. So it played a part in this Eureka. The NTAS, if you remember, buoy, I mentioned that when we were looking at the study area, the Northwest Trade Atlantic Station, that buoy also had a great amount of instrumentation on it, and you can see the different types of instruments and the different types of measurements used for those instruments. We had gliders. Gliders were deployed from the ships. These were drifting platforms. They were deployed from, I know for sure, from Ron Brown. And they also recorded oceanic and atmospheric information or measurements. And we're looking at the platforms that were the aircraft. So the aircrafts themselves had a vast variety of instrumentation. So I'm just going to look at a few for you to have an idea. So the first diagram at the top is called the drop sound. So you drop sound, when you drop it down, drop it from the aircraft down to the ground, it measures temperature, humidity, and wind. And so you have a better idea of what's going on in the atmosphere vertically. They also had an extensive array of radar and LiDAR equipment and some passive remote sensing instrumentation. And it was mounted in what we call the belly pod here. And it was interesting. And they had some other equipment that was very significant and important to the objectives that the Eureka 4A wanted to meet. You can see a beautiful picture here from the same Halo aircraft, showing some of the clouds, some of the same cumulus clouds as well. Another plane that was significant was the French ATR-42, and they flew in the lower troposphere, probably going as high as 8 kilometers. The instruments they had was very significant. The raster radar, which is a type of cloud radar. They had 4 antennas, so they had 3 on the top of the plane and 1, I think, at the bottom. And it was able to help characterize the cloud microphysics and the cloud dynamics. So you were able to see it in 3D. So if you look, you can see some of the imagery that was, some of the images that were portrayed out from that radar. And you can also see there was some dust there. So it made me very happy when it was on that flight. And for the most part, those are some of the instruments that were on some of the flights. So the first 3 top were on the Halo, and the last 2 are based in the ATR, the French plane. Okay, so more instrumentation, but as I said, we identified some of the major ones that I think were significant, but there's so much more that is also significant that we don't have time to go through. So as I said, I'll just highlight some of the major ones. The Cloud Kite, which was on the research vessel, the MS Miriam. So then they had 2 small ones on the Meteor, the other German ship. And the instrumentation on the Cloud Kite, the first image you see there, included the weather sensors, cloud drop probes, and some other instrumentation as well. We mentioned the sail drone, which is the second picture in the center at the top. And the 2 pictures that you see on the right, one on the bottom, those are obviously drones, air drones, aerial vehicles. The one at the bottom is the Boreal, and that was flown in coordination with the Halo and the ATR and the Twin Otter, all the air flights. And that flight, that was a lot of flights, like 1 6-hour flight per day. The instrumentation found on this particular aerial vessel is your condensation particulate counter, you had weather sensors, you had solar irradiance, you had some equipment that was used to detect clear skies as well as cloud coverage. So for us in the Caribbean, one of our major roles in the Caribbean was obviously I don't know how strong to say we understand, but we have a vast knowledge of our area in terms of the weather activity that goes on. So in December 2019, the Caribbean Meteorological Organization, CMO, and the University of Leeds, as well as with CIMH, organized a Caribbean forecasting initiative or workshop to promote that knowledge exchange between the researchers, the researchers for Eureka, and the forecasters from the region. This activity was a support for the forecasting testbed for Eureka 4A. So the first image is where the workshop happened, which is 2019 in December. During the campaign, the same meteorologists were allowed to come back in via CIMH, and also they did brief bulletins for the weather and oceans daily for all platforms. So they did briefings for the ocean platforms, which is the ships. They did briefings for the aircraft. They did briefings for the land-based platforms. So those who couldn't make the briefing, which was based at the Barbados Meteorological Services, were still able to get the information, obviously remotely. This I believe was one of the major collaborative efforts between the region and the visiting scientists from Europe and Americas and other areas. And for the most part, the scientists expressed their appreciation for what the forecasters contributed to their investigations. Because again, these forecasters would have a better understanding of the region in terms of the atmospheric conditions and in a sense, some of the oceanic conditions. Okay, so we can see that some of the experiences that some of our colleagues experienced. We had some colleagues that were on some of the ships. We have Wim McGarry there assisting with the balloons, the radio sounds, as well as I think he assisted with the CTDs on Ron Brown. We had a young intern on the Cloud Kite team, and the Cloud Kites, as I said before, they were on the Meridian. We had flights with our forecaster. We have flights ourselves to see the equipment in action of some of the aircraft. You will see some of the forecasters, meteorologists, as well as myself and another forecaster. And for the most part, the belief was that this information was so significant to us in the traffic staff. We were actually very grateful that the information is being looked at. And we, for the most part, if you spoke to some of the forecasters and the meteorologists that took part in these activities, they would say that this information is more impacting on the data collection. The process was more impacting than just reading an article or just reading looking at a diagram. Okay, so we have some more young people. So as I said, we are young scientists from the region. We had them, some of them took part, as I said, in all the activities, and they also spent time on, I think we had Alton was on the Brown Brown. He spent a couple of weeks on the Brown Brown working with the teams. Keyshawn, the gentleman here in the corner, he also was on the Viren research vessel, and he spent some all 3 weeks there. This young lady here would have been one of the persons assisting with the planning of the forecasters in terms of the briefings. And here we have some of our our interns and some of the young scientists from the Eureka program working together to get some of their outreach activities out. So it was a great collaborative effort by all to get this program running. So as I said, the outreach program for Eureka 4A was quite intense. It was quite vast. We wanted to, the organizers wanted to make sure they give back to the country that gave so much, as well as the region. So we had a lot of, a great amount of visits from schools, students probably 15 and up, to a lot of the research vessels once they were in birth. We also had a public lecture. Professor Stevens and some other of the renowned scientists also presented at this lecture to talk about trade winds and what the Eureka was doing and why we were doing it and so forth. We had some of the young scientists, region's young scientists, as well as the Eureka's young scientists, do a lot of school visits. They visited primary, they visited secondary, and it was very pleasing to see the reaction from the students and to learn more about what the research from Eureka 4A was about. We had open house for some of the land-based platforms. For sure, BCO, Ragged Point had open house on a couple of Sundays. We had open house with respect to looking at the drones as well. And one of the major activities that we are pretty proud of was the Eureka 4A International Symposium, whereby we streamed it live via Facebook, Facebook Live, obviously. And we had I want to say at least 200 persons, not on site, but we had remotely, we had a lot of persons linking in to hear the different researchers, be they regional researchers or international researchers, sharing information relevant to Eureka and some of their research that they were doing that we're not aware of. So the International Symposium was considered to be quite successful. We had weekly seminars. So as I said, it was very intense. We had weekly seminars, and with the weekly seminars, we mainly had young scientists, regional young scientists, as well as young scientists that came with the Eureka or with the institutions in Eureka, sharing their research on a weekly basis on Friday evenings for an hour and a half. We had these activities. We also made it available remotely. So we had a good, probably 50 plus, 70 plus persons logging on to listen to these different young researchers. And the discussion after, with the mix and mingle after most of these seminars was very in-depth and significant. And I think most of the researchers, when I spoke to them, the young researchers, when I spoke to them, learned a lot from each other. And another important point to note is the Polaroid station in Collington. I mentioned before, the land station, or the land platform. And this particular platform, it was manned by DLR and CIMH staff during the campaign, but it was decided that after the campaign to leave it for a few months. And in leaving it there for a few months, we had some eventful data that was collected. So it was manned actually by CIMH staff, mainly some interns, 2 officers, myself as well, where I tried to help man it as well. And the data collected during that time was very significant, actually. We had some great thunderstorms, so we collected some great imagery. So these are examples of some of the data collected. Again, some of the data hasn't been fully published. It's actually has been submitted. So for example, you have data collected from all of these platforms that can be analyzed together to give you a better feel of what's going on as in the atmosphere as you ascend and as you descend. So the ascending was the radio songs and descending was the drop songs. You have other data here where we looked at imagery. We look at this particular fish pattern, we call this a fish pattern, and we could be able to pull data based on all the other platforms that are available to integrate this information and to analyze what's going on at the same time with, like, for example, the your relative humidity and what's going on with respect to the clouds at the time. And this information was put together or given together to give you that type of, you know, that 3D feel of all of what's going on in the atmosphere. Another set of data that was collected, you see, for example, you see here, you have the LiDAR showing you some influx of Sahara dust. This particular day, the Ron Brown, which is the research vessel, the ship, and the Ragged Point, which is the land vessel, showing collection of CCNs, which is your your cloud condensation nuclei. And you can see there is an overlap with the Ron Brown, as well as the Ragged Point information, CCN. So again, the data collecting from various platforms played a special or most important role with respect to how we're going to look at clouds, how we're going to look at what happens in clouds. So all these platforms played a significant role. Also here we had the different platforms which showed cloud sensing instrumentation. So you had platforms from the Halo, which is your aircraft. You had the Twin Otter, which is another aircraft. Your Polaroid, which is your land-based platform, your airplane, and your cloud kite. So all this information can be put together, to demonstrate a three-dimensional distribution of individual cloud droplets and so forth. So a lot of information was gathered during this campaign. For the oceanographers out there, obviously a lot of data was collected. There was CO2 collected, the sea gas, the sea grass, information was collected as well, because there were some seagrass or sargassum materials along the research areas, for example, your trade wind alley. So it was very significant to see these activities occurring. The data will also be used for modeling. Sorry, the video is not working well, so I would hopefully try to get that started and have Valentina, one of them, put it up. But the data is also used for modeling, because we know climate-based modeling still needs a lot of work with it. So therefore, this data will actually be put into some climate models to ensure that we have some form of ground-based data. You know, ground-based data is quite important in terms of modeling. So what is the future for Eureka? Obviously, the analysis of all this data, and this significant data. There's a possibility of the convective experiment with the intertropical convergence zone in 2024. Hopefully this can happen. We know we're going through COVID, so we're not sure. Creating a science island, a small scale island like Barbados would be great for, and long-term collaborations which have been going on over the years and will continue to go on, hopefully, as we move forward. So if you're interested, you could actually find some of the articles that were submitted on the site here, the Earth System Science data site. There is a Eureka movie. I will have that for Yes community so that they can have it up as well. And there's data available from the Eureka field campaign, open source data. So the link is the third link here. You can actually don't get the data for the most part. It's open source once you go to that link. So your contact persons, as you can see who they are, and they are willing to listen. There's room and there's opportunity for collaboration with all scientists relevant to what was collected. There's a lot of data collected. So if you have time, you check the site and see what kind of data was collected. There's a possibility of another field study. So, you know, if you can collaborate with other scientists, you do that. And actually we celebrated our 1-year anniversary last night. We had an online party, I couldn't make it. but we celebrated our 1 year anniversary because remember we started the 20th of January last year. We did the campaign from the 20th of January last year. So I would encourage, especially young scientists, if you can, to review the data that is there. You never know how you can collaborate with some of these scientists, young scientists, as well as, for lack of a better word, seasoned scientists, because the data was monumental and it's there and available. And if you want to work with it, you can. So thank you for listening.
Thank you, Rebecca, for your presentation. We'd like to start the discussion now. So if you have any questions, please write them in the chat box and Rebecca can answer them.
Okay, please comment on why Barbados deserves an ideal platform for studying the relationship with, among Sahara dust, cloud formation, and circulation. Well, Barbados is the most eastern, actually we are completely outside of the Caribbean chain, and we are the most eastern. We have, as I said, we have had a station that has been recording the dust particles, the aerosol information for the last more than 50 years, I believe. So therefore, the data is the for lack of a better word, the infrastructure was there from before. So it makes it easier. And then with the areas that they want to study along the trade wind alley, as well as coming from the south, made Barbados an easier area to have your base of operations for this particular study. So as I said, the infrastructure was there before. The BCO, the Max Planck, CIMH, as well as the French counterpart, were having conversations before this. They were having these conversations together a couple of years ago. So that is why Barbados probably had become the main base of operations. What sort of data collected on the drones and types of sensors attached to the drones? I think I mentioned that they had weather sensors, of course. I said some of them had condensation counters. Some of them had, there's a lot of instrumentation. But what I said, if you look at the first link I have there should be a paper submitted that you can access all of the sensors, all the instrumentation that was on the particular drones. Does the sensors or analysis affect the weight of the drones? Oh, that's technical. I don't think so. They probably produced them to ensure that because they flew. So I would assume that they created them to make sure that everything weighed effectively. And they did full 5-hour, 6-hour flights. So they worked pretty well. In addition to measuring aerosol size distribution, are there also aerosol chemistry measurements? Yes, I believe there are some. Ragged Point, as I said, has been doing it for a long time. So they're more likely will have some chemical measurements. I think BCO, but you could always check the site and find out, but there should be some aerosol chemistry measurements. I guess I did a very good explanation of the Eureka.
Yeah, I think, there is one more question.
Okay,
and
great.
This one is saying, how does extreme weather such as storms affect the BCO in terms of structure and etc.?
Well, you realize the BCO, once we know a storm is coming, we take down everything, obviously. But you realize the BCO is those metal containers, and they're actually bolted into the ground, and that's out there, that's relatively a cliff, hard stone. And it has been, as I said, it has been out there from 2010. So usually when you know weather is coming or severe weather is coming, they take down all the materials, all the equipment that is on top of the containers, actually pack them up good, and hopefully I don't think we have had any significant issues when there is intense or extreme weather. I hope that answers your question, Mohammed. Yes.
So thank you, Rebecca, again. I think there are no more questions. Otherwise, they can write an email to you and contact.
Yeah, because I forgot to put my email. So let me put it inside of the chat.
Yeah.
The gentleman that asked about the agro, if he wants to get back to me.
Yeah.
Because we have 2 agro meteorologists on staff. So if I can't answer, I know somebody who can.
Okay. Now we like to close the webinar. Thank you again, and have a nice week, everyone.
You too as well. Bye.